Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. We want to present our design of wastewater treatment plant at Pago District. First of all, I want to introduce my group members. Firstly, Nur Iryani binti Saleh. Secondly, Nurul Izzati binti Abdul Rashid. Thirdly, Nurul Hanisa binti Saidin. And lastly, Nurul Ain binti Nordin. In Malaysia's population is expected to exceed 40 million by 2050. According to the 2018 revision, Asia's urbanization rate is now approaching 50% and is expected to rise over time. Because of that, more efficient wastewater management become necessary. The efficient management of sewerage system is critical in contributing to the nation's goals and aspirations for a service that is both technical and environmental in nature. As a result, it is vital for the consultants involved, especially for engineers, to design a wastewater treatment plant that meets the federal, state and local effluent quality standard stipulated in applicable discharge permits. The objective of this study is first to provide the detailed design of the wastewater treatment facilities, second, to design the primary wastewater treatment, and lastly, to propose the suitable biological treatment for the wastewater treatment plant, sludge treatment methods, and effluent disposal. To find the wastewater flow rates, first of all, we need to calculate the total of population equivalent based on the premise that we have. The total population equivalent for these studies is 4,920. Then the peak flow that we got is 4,366.46 meter cube per day.
Assalamualaikum, my name is Nurul Izzati. So, to design bar screen, it started by designing primary screen. It was designed based on design parameters of primary screens from MSIG, where the depth is 0.5 meter with free void of 0.3 meter and 13 bars with width of 0.01 meter and clear spacing of 0.025 meter. After primary screen is secondary screen. Same as primary screen, the secondary screen was also designed based on design parameters of secondary screen from MSIG. The perforated plate dimension is 0.5 times 0.25 times 0.15 that results in 0.019 meter cube, which is able to accommodate since it is larger than the quantity of screening. Besides, the inclined length of the bars is 1.13 meter and the total length of the screen channel is 1.95 meter.
Next is the design of grid chamber. Parameters shown here is the parameter of grid chamber and we design based on PE less than 5,000 criteria. The design of grid chamber in this project is manual and have 2 tanks of it. In this design of grid chamber, peak flow for one tank is 2,183.23 meter cube per day as we use 2 units of tank. And then the volume for each tank is 84.96 meter cube. Solid loading rate is 28 meter per day and says that the settling velocity with allowable settling velocity is 0.0004 meter per second, and this shows that this grid chamber is compliant with all criteria needed.
Hi, my name is Hanisa binti Saidin. I will present about design of primary sedimentation tank. For this project, we designed 2 units of circular sedimentation tank. This table shows the design parameter for primary sedimentation based on Malaysian sewerage industry guideline. The average daily flow in each tank is 553.5 meter cube per day. The peak flow for each tank is 2,180.79 meter cube per day. The surface area of each tank is 40 meter square. The diameter for the tank is 5 meter. Based on Malaysian sewerage industry guideline, the detention time is 2 hours. The volume of the tank is 47 meter cube. The site water depth is 3.4 meter. the required site water depth based on MSIG is in range of 3 to 5 meter, so this value is acceptable. The mass of primary sludge generated is 4 kg per hour. The volume of primary sludge produced is 0.08 meter cube per hour. The capacity of sludge pocket is 0.32 meter cube. The hopper capacity is 0.43 meter cube. Since the hopper capacity larger than capacity of sludge pocket, so it is acceptable. The depth of bottom slope is 0.15 meter. Total depth of tank is 4.45 meter. Diameter for feed pipe is 40 mm. Meanwhile, diameter for sludge removal pipe is 200 mm. This figure shows schematic diagram of primary sedimentation with sludge pocket.
Biological treatment is to treat use of organic matter in waste, which is usually physical pre-treatment done first to remove solids before biological treatment. The wastewater treatment methods for biological treatment are categorized into aerobic and anaerobic. The operating cost of aerobic is less than anaerobic. Thus, these wastewater treatment facilities choose aerobic treatment, which is stabilization point. Besides, the land is readily available at relatively low cost. Using this kind of treatment is also easy to operate, less energy required, and equipment maintenance and better sludge thickening. Based on the previous studies, the construction is simple and consists primarily of earthworks, and the operational costs are significantly lower than in other treatment methods.
This flowchart shows the process of sludge management. Gravity thickening is proposed to reduce the sludge volume. This gravity thickening can be achieved in circular tanks similar to sedimentation tank, where the sludge is allowed to settle and compact. The next process is sludge stabilization or digestion that used to convert the organic solid in sludge to more refractory or inert material. For this wastewater treatment, aerobic digestion was chosen. Aerobic digestion functions as extension of activated sludge. It can be accomplished by aeration of sludge, then followed by the sedimentation. After that, the dewatering is implemented to reduce the water content before the sludge being disposed. Sludge drying bed has been proposed since it is simple and requires low maintenance.
The major aim of wastewater treatment is to remove as much of the suspended solid as possible before the remaining water, which is called effluents, is discharged back to the environment. Common effluent disposal procedures include discharge into bodies of water, disposal in evaporation ponds, deep well injection, and so on. Effluents may be released to the main sewage network or in certain situations directly to surface or groundwater. A conventional trench has used in this project. This is alternative to aggregate for the absorption field trenches such as chambers and gravel-less trenches, while slightly more this method is slightly more expensive and it's attractive to both homeowner and other facilities of this ease of transport, which is quick installation such as the small area in Pago, and rapid expansion of wastewater management service is small communities is very necessary to address concern over water scarcity, water pollution, and public health protection. Effluent disposal to small communities require the adoption of cost-effective solutions that are affordable to the community and national economies.
In conclusion, it can be concluded that all dimensions of wastewater facilities that have been designed earlier were based on MSIG so that the environment will be free from pollution, especially water. As for the biological treatment, this wastewater treatment facility chose aerobic treatment. For the sludge treatment, gravity thickening was used, and for effluent disposal, conventional trench has been used. Thank you.